Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.112. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.112. Find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this 4 kilo ohm resistance labeled as V0. So without wasting time, let's proceed towards the solution. First of all, if we observe, this is a closed loop network and the value of voltage is required. So we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this resistance. For that purpose, we have to assume the direction of current. If we focus in this scenario, current I is flowing in this network in clockwise direction. So we will mark polarity notations across resistive elements according to the direction of current. Current entering terminals are taken with positive sign and current leaving terminals are taken with negative sign. Now write KVL equation for this closed loop. Start from here. Current entering terminal is positive. So voltage across this 2 kilo ohm resistance will be taken with positive sign. Next, current entering terminal is positive. So voltage across this dependent voltage source, that is the twice of V0, will be taken with positive sign. Next, current entering terminal is positive. So V0 will be taken with positive sign. And at the end, current entering terminal is negative. So 24 volt will be taken with negative sign. Now we have to find the equations for voltage across this 2 kilo ohm resistance and V0. For that purpose, we will use Ohm's law. Current I is flowing through this closed loop network. So voltage V0 will be equal to the product of current I and the value of resistance 4 kilo ohm. Similarly, voltage across this 2 kilo ohm resistance will be the product of current I and 2 kilo ohm. Now update this equation by replacing V0 and V2 kilo ohm with their values. Voltage across 2 kilo ohm resistance is the product of current I and 2 kilo ohm, and voltage V0 is equal to the product of current I and 4 kilo ohm. Take the product of current I and 2 kilo ohm. It will become 2000 I. Kilo is replaced with 1000. Similarly, the product of this equation is converted into 8000 I, and product of I and 4K became 4000 I minus 24 volt equal to 0. Now place minus 24 volt on the other hand side of equal and add all these variables together. Their sum will be equal to 14,000 I equal to 24. Divide on both sides with 14,000. The value of current I will be 1.714 milliampere. After calculating the value of current I, this value will be placed inside this equation to calculate voltage V0. Product of 1.714 milliampere and 4 kilo ohm will be 6.86 volt. So the value of voltage across this 4 kilo ohm resistance is 6.86 volt. This was exercise problem number 2.112. Thank you. See you again in next video.